Hey guys, today we're going to start to kind of get away from graphing. Some of you may be relieved to hear that. And we're going to kind of take the next couple of lessons and break them up over a few days. And we're going to start by talking about rational expressions. And we're going to start with just simplifying rational expressions. It's something that looks a little different than maybe what we're used to. But remember from lesson 9.3 that a rational expression is written like this. It's written as a polynomial over a polynomial. So x squared minus 1 over x squared plus 2x plus 3. That would be the example of a rational expression. And it's in simplest form when its numerator and denominator have no common factors or divisors, just like when we're simplifying fractions. So let's start off with a couple of monomials. We've got simplify the rational expression and state any restrictions. We'll talk about that second part here in a minute. So because there's nothing being added, subtracted, they're just being multiplied, I'm going to look top to bottom with the like terms. And by that I mean I'm going to look at the constants, then the x's, and then the y's. So negative 27 over 9. Well, that is pretty simple. I can just write that as a negative 3. All right. And then the y's, I notice, cancel out. Now, with the x's, we are in the habit of saying that we take the numerator divided by the denominator, so 3 minus 4, but that would give me a negative 1. I would say, instead, let's think about it this way. Which exponent is bigger? Now, subtract that exponent minus the other one and keep the x where it's at. So this x is bigger, or has a bigger exponent, so it's going to stay in the denominator. Then I'm going to do 4 minus 3, which is 1, and so that means this would be my final answer. Hey, that's not so bad. You just simplified a rational expression. All right, now we're going to simplify again. If I look at my numerator, this is where you're going to maybe need to dust off some of your polynomial skills and quadratic skills. The first thing we always look for is GCF. And the GCF of this numerator is going to be, I'm going to say, let's go ahead and take that negative 3 out. So that would leave me with a 2 plus x all over. And factoring this into two sets of parentheses, I would write the parentheses, split up my x's, what multiplies to 8 and adds to 6, 4 and 2. Same sign, both are negative. Now I'm going to look top to bottom and see, is there anything that I can cancel out? And in this case, no. Now, a lot of people say, but this has an x and this has an x and this has a 2 and this has a 2. In order for anything to cancel out, with the exception of it being like this, where it's monomials, here I could cancel out the numbers and the y's and the x's because they were all just multiplied together. But when we start adding things, in order to cancel them, I would have to have the same thing in the numerator as the denominator for the full expression. The minute that I change something about that, I cannot simplify it anymore. So this could not be simplified, but if I didn't have that 3 there, I could cancel out x plus 2 and x plus 2. So even though these two are just a sign away from being the same thing, and even though these both have an x, I can't cancel anything. So this is my final answer. This is already in simplest form. Now, I forgot to go back to the state restrictions on the original or on the first problem, but let's do that here. So restrictions just mean what values could you plug in that would make this not work or not be true. And we should know by now that the only thing we can do to make this not be true is to plug in a number that makes the denominator equal 0. So if if I were to look at this problem, I could go back to the original problem where I could say, hey, I've already got this right here. The values that cannot be plugged in for x would be a positive 4 and a positive 2. Those would be my restrictions. All right. When you simplify this numerator, what do we get? There's no GCF, so I'm multiplying that 2 to the end, and I get x squared minus 3x minus 4, which gives me x minus 4 and x plus 1. So there's my numerator simplified. What do we get when we factor the denominator? x minus 3 and x minus 2. Both are negative. So anything that we can simplify there? Oh, I forgot something. All right, rookie mistake. I forgot up here to go back and divide by 2. So when I divide by 2, that's going to give me x minus 2, 2x plus 1. So now, looking at this, what can I cancel out? I can cancel out the entire expression x minus 2 and x minus 2, but the rest of it has to be left alone. So I get 2x plus 1 all over x minus 3. And that's it. That's the whole problem. I do need to state the restrictions. So again, it's stating the restrictions is just another way of saying set that denominator equal to 0. But I'm going to skip over to this part right here before I did any canceling, because in factored form, it's easier to find those restrictions. So I would say that x cannot equal 3 or 2, because when I set each of these parentheses equal to 0, that's what I get. All right. What should we do first on this problem to simplify it? GCF, GCF. All right, so 3x squared plus 4x minus 5, x squared plus 4x minus 5. All right, so I factored out my GCFs. So now I could factor those quadratics, but they look exactly the same. So since I have x squared plus 4x minus 5 written 2 different times in the numerator and the denominator, I can cross those out and say that my final answer is just 3 over 2. But I should still simplify that denominator so that I know what my restrictions are. If I factor that, I would get x plus 5 and x minus 1, which means that x cannot equal negative 5 or a positive 1. All right. This really isn't too bad, but I wanted to take some time to really practice the simplifying part because it kind of helps build the foundation for what is to come. That is all I have for you on this lesson. If again, we'll go over some practice problems together, but if you have questions, please do not hesitate to let me know.